Okay, Algebra 2 students, here's a video for example 2 for section 3.1. Understanding end behavior of polynomial functions. How do the sign of the leading coefficient and the degree of the polynomial affect the end behavior of the graph of the polynomial function? Though a polynomial function may have many terms, the leading term determines the end behavior because it has the greatest exponent and therefore the greatest impact on the function. Okay, so that's why all we have to do is look at the leading coefficient. All right, let's look for patterns here. See if I can get this to fit on the screen. Let's say we have an odd degree with a positive leading coefficient. For example, okay, an odd degree. So this has a degree of 1, this has a degree of 3, this has a degree of 5. Okay, the red, blue, and green all have odd odd degrees, and the leading coefficient is positive 1, 0.5, and 2. Okay, they all kind of go from down here to up here. And that's what it's written here. As x gets larger, or as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. In other words, as x gets smaller, y is getting smaller. As x gets larger, y is getting larger. Okay? Now let's look if it's an even degree with a positive leading coefficient. Okay? X to the second, x to the fourth, x to the sixth with positive numbers. It looks like it's starting here, comes down and goes back up. So how they write that, they're talking about as x approaches positive infinity, y is approaching positive infinity. As x approaches negative infinity, y approaches positive infinity. So this one, because it's even, it approaches positive infinity as you go to negative infinity, and as you approach infinity, it goes to infinity. I think that might have confused you. Basically, it's going to start up here, come down, and go back up, and it has a local minimum. All right, moving on. How about if it's an odd degree with a negative? So the same thing as the first thing. Remember that? The first thing was it did this. Well, if we have a negative leading coefficient, it just goes the opposite direction. As x, well, I'll just click it over here. As x approaches infinity, y approaches negative infinity. As x is getting smaller, y is getting larger. The way I memorize it is, if it's an odd degree with negative coefficient, I know it goes from the upper left to the lower right. And if it had a positive leading coefficient, it would go from the lower left to the upper right. If it's an even degree in positive, I know it starts in positive, comes down and goes back up to positive. If it has an even degree but it has a negative leading coefficient, they start in the negative world and end up in the negative world. Okay? I mean, there's the terminology, but basically, can you tell what's going on? Let's look at the examples you have to try. It says use the leading coefficient and the degree of the polynomial to determine end behavior. Okay, so here are two. Click pause and come back when you're ready. Okay, leading coefficient. I have 6, 5, 4, 3, 2. Okay, good. This is in standard form, so I know this is all I have to look at. It's an even exponent. That means it's either going to go from, it's either going to be a U or an upside down U type thing. And it's a positive number. So even though I didn't put it on the Jamboard, let me just add in a board. Let me add on a page. Should have done this already. I apologize. All right. What was that one? 2 with a positive number with a 6. So I know positive number with a 6, it's going to do that. I mean, it might go up and down a couple times, but basically, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y is approaching positive infinity. Let's see what they wrote. And that's what they wrote, even though they used a different notation than what they had in the notes. All right, how about this one? This is an odd one, odd exponent, with a negative coefficient. So I would say, I'll change colors. It's an odd, so I know It either starts here and goes up to this way, or it starts here and comes down to this way. Do you remember which one was which? It had a negative leading coefficient, so that means it's this one. So as x approaches negative infinity, y approaches positive infinity. As x approaches infinity, y approaches negative infinity. Let's see how they wrote it. The leading coefficient is negative and the degree is odd, so yep. I mean, that's what I said. I said it in words, and they're showing it out in their notation there. All right, that's it for this video. Let's see what your teacher can assign. We're in section 2, so there's only 3 problems in the text that are related to that: 21, 22, and 23. This is off of page 137. That's it for this video. Have a great day.